Okay, in this video, I'll be going through the 2021 Yishun Town Prelim Paper 3. I will focus on question 2 and question 3. If you want to find out more on your question 1, you need to search for another video. So let's skip ahead. For question 2, I think you all did pretty well. So here I would focus on your part G. So for your part G, maybe before I go into part G, I will just quickly recap on what you have done. Okay, for this particular experiment, you are asked to do a pendulum, and you are supposed to measure the time taken for a few oscillation, and then after that you are supposed to find the period. So as a good practice, whenever you are being asked to find the period of a pendulum, please make sure that you are measuring the time for multiple oscillation. Okay, so try not to just do one oscillation and then that is the time, that is the period that you are measuring. It is very inaccurate. The reason why is because usually your period is in the range of, let's say, 1.5 seconds or something like that, but your human reaction time is actually about 0.3 seconds. And when you want to time the period taken for one oscillation, you will have to react once when you start the stopwatch, and you have to react another time to stop the stopwatch. So actually your total reaction time is 0.6 seconds and your period is 1.5. So in another word, right, your error actually takes up almost 1/3 the amount of what you actually want to measure. So as a result, it is not a very accurate way to measure the period just by timing the time taken for one oscillation. So as a rule of thumb, try to do it for 3, 5, or even 10 oscillations, whichever fits your context. So for this particular case, you will find that when you put the pendulum in water and you want to swing it, actually the amplitude will decay very, very quickly because of water resistance. And as a result, if you want to do 10 oscillations, sometimes you may not be able to observe the 10th oscillation. So ideally for this experiment, for myself, I do 3 oscillations and then I just take the time divided by 3 to get the period. So after you have done this, you would have obtained some value for your T1 and you would have obtained another value T2, which is the period when the pendulum is swinging in water, right? And basically the question wants you to come to a conclusion whether or not the period of oscillation is it dependent on the density of the medium. Okay, so in another word, the statement here basically is trying to say that mathematically they believe that T1 should be equals to T2. This is the meaning of independent, right? I mean independent of the density of the medium, because T1 you are taking the period in air and T2 you are taking the period in water. So in another word, this statement is trying to claim that your T1 is equals to T2 and they want you to comment based on your result, right? And they actually give you this piece of information that the human reaction time is 0.3. So many of you didn't realize this, that this 0.3 seconds, right, is plus minus, meaning that when you react, you may take a longer time, right? That means if, let's say, the actual true value is 1 second, you may have taken the time as 1.3 seconds, but it also means that you may press the start or stop button too early. So you may be able to get something like 0.7 seconds. This is the meaning of plus minus. And they are not saying that your reaction time must be in multiple of 0.3. It can be 0.2, it can be 0.1. So in another word, right, they are trying to say that if you have a certain measurement, your actual timing would have to have a range of minus 0.3 and plus 0.3. And so if you have T1, you will have this range of value, and T2 would have another range of value. Okay, so this is the meaning of average human reaction time. It is plus or minus. So for example, let me give you an example to illustrate this. Let's say T1 you get 1.4 seconds, and T2 you get 1.8 seconds. Whether this thing match, right, you need to see it this way. If I have 1.4, it means that I would have a range of 1.7 to a range of 1.1, and 1.8 would mean that I would have a range of 2.1 all the way to 1.5. This is the range. And if you want to see whether they match or not, right, you need to do it this way. So you have a number line. So I have 1.1, 1.7, 1.5 will be somewhere here, then 2.1 will be somewhere here. So T1 will basically occupy this range of number, and then T2 will occupy this range of number, right? So if you look at this range, you can see that there is actually a chance that T1 can be equals to T2, right? Compared to, let's say, another set of reading. Let's say another set of reading you get is 1.1 to maybe 1.7. Let's say this is the reading you get. And then after that, you get the other set of reading is maybe 1.8 to 2.5. So let's say T1 will occupy this range, and then T2 occupies this range. Can you ever get T1 to be equal to T2? No, there's no overlapping. So we say that T1 can never be equals to T2. So that is the general idea of how you can use the average human reaction time. And do not forget that for this particular value, this is for one reaction. When you want to take timing, right, you will have to start your stopwatch and you will have to stop your stopwatch. Each time you start and stop, right, you are reacting. So it means that the combined reaction time for your period, right, is actually plus minus 0.6. So it means that this particular case, what the person need to do is, I need to add another 0.3. 1.7 plus another 0.3 would be 2, right? Then here would be another 0.3. Then for here, also another 0.3. Then for here, another 0.3, so that you have a total reaction time of 0.6. So for this particular question, you will have a very wide range, and chances are T1 and T2 will be equal based on your argument, even if you are looking at a timing that is for 10 oscillation or 5 oscillation. So for this particular question, what we are looking at is two things: whether you took the hint and that you are judging, you are making your judgment based on this human reaction time. So like I said, this is quite a difficult question, so we lower the marking demand. But technically speaking, right, when you want to consider the human reaction time, you should consider a human reaction time of 0.6 seconds because you start and stop your stopwatch. Now you can apply this human reaction time to either, we accept that you apply it to either your timing for 10 multiple oscillation, or you apply it to your period directly. But if you ask me which one is more accurate, then of course it is for the multiple oscillation, because that is how you take the measurement. So that is how you should approach this question. Okay, so this kind of question, when I set this question, I actually took inspiration from one of the MCQ question, which actually requires you to approach the question like that lah. You are given two readings, and then they gave you a error range, and the easiest ways to visualize whether these two reading agree or not is to actually draw out the number bar. So if the number bar overlap, it means that there is a chance whereby these two reading coincide. Yeah. and that's how you should approach this question.